I think I'm streaming. Hi, Smitty here. Working on the second part of my board layout for the mic splitter project that I've been working on. I'm going to go into a very brief summary of what it is, but go look at previous episodes for some details. Hi, let's get started. So, really quick summary. Here's the schematic. Power supply section over here, false ground. Mic input connected to the laptop and to the mic itself. Grab a tap of that, buffer it, and then feed it into 3 different driver amps, audio transformers, and then output connectors blocking the DC. Right? Remember all of this. We've talked about this in previous episodes. Yada, yada, yada. I'm not going to go into the details on that again. Then last time we did this, I got started on board layout, and by started on, what I mean is I pulled the components in, and that was about it. You know what? I'm looking at these capacitors, and I want to swap those out. So I'm actually going to go back to what am I talking about? So these capacitors, the physical outline for this is meant to either take a 0.1 spaced or maybe a 0.2 spaced capacitor and a 0.3 spaced capacitor. So it could use capacitors of many different sizes. It just kind of gives you a lot of options when selecting components, but it makes layout harder because you can't fit a trace between those two. So I want capacitors that I'm going to be able to fit a trace between. So I'm going to go back over and change that. I was working on a different board this morning and I kind of ran into that problem. And so I want to learn from those mistakes. Rectangular. All of these. You'll notice that these have the P250 and P5 or 2.50 millimeters, 2.5 millimeters, and 5 millimeter. Those are the pin spacings. So it'll take either the 250 or the 5.0, and I want to replace those with just the 5.0 versions. So let's do that. See rect. There it is. And so that's the 5.0 version of it. Okay. So that'll be a simpler component. Okay. Save that. So we're done that. Generate our net list. And then head back over to the board. Oop, wrong one. Just kidding. So head back over to the board. Now this is the interesting part. When you read a net list, if we changed a footprint in the source, it will normally keep it and not swap that out unless you click that button. Similarly, if you delete something, it won't actually delete it unless you click that button there. So we're going to go ahead and read that net list. Yeah, I know, this cannot be undone. Transformer. Oh, yeah. So the transformers I chose didn't have holes for the shields. So the schematic outline, or the schematic component and the board outline don't match. That's okay. So we got that, and now all of my capacitors only have the 2 pinholes. So that'll make layout a lot easier. Okay, so let's start with power. So I kind of started with that up here, and we have the USB connector and just the external 2-pin. I'm going to open up the schematic on a different screen. You won't be able to see the schematic, but I can. So I'm using this for reference. Glad to see I'm not the only one bad at relaxing on holidays. Hi, Benjamin. Yeah, this is relaxing. I consider this relaxing. This is a hobby for me. So yeah, this is relaxing. I don't know what you're talking about, man. I'm totally enjoying this. Time for you to come heckle me. That's how you relax on holidays, right? That's what we need. Okay. Sorry, I'm setting up my second monitor so that I can see my YouTube stream, make sure that's healthy, see OBS so that I know when I accidentally don't switch back to the right view, and then also still have the schematic open. Okay. So we got the USB connector in this thing, and then that just goes into parallel with a filter cap here, then a voltage regulator, and then another cap, and another cap. Okay, so that's really Yeah, that's that. Okay, so we'll do that. You know what? Hold on. So something else that we can do. I don't like super thin traces. It's the audiophile in me. I like having thicker traces for at least some things. So those are 0.01. I'm going to make a different... So this is the design rule editor. You can have different classes of nets, and default is 0.01 inch track width. But I want to have some that are 0.02, a little bit wider. And so I just create a second category of traces, set this side up for that second category called power, and then we're going to route our... I don't think ground A needs to be that, but ground definitely... I gotta find out what that one's called because it's not a named trace. C1 pad 1, that'll be it. C1 pad 1, because I'm looking, there's C1, that's my filter cap, and pad 1 is the positive, so I'm looking for this net right here. And we'll start out with those, and then if we run into any others we can do that. So I've created a new class of nets called power. I've set it to 0.02 track width instead of the 0.01 on the default, and I added these nets to that class. So now when I lay down a trace, it'll be a thicker trace. Oh, yeah, that's beautiful. What the what? Ha! Okay, go home, router. You're drunk. Why are you not? Because the trace is wider than the pad. That's lovely. Okay. So maybe I can't do it that way. Design rules. 1.9. Here, actually, I can do this. What is the width of this pad? 177. So if I set a trace width 177, now it should go. You are so drunk. What are you doing? There we go. Okay. So that's our power in and our power out. We'll do that. Okay. So that is our power system. No heckling for me. I actually like electronics quite a bit, but I'm working on software for one of my projects, and it feels like work. That's fair. I don't exactly get around to doing a lot of the Unix and network administration that I used to do as a hobby now that it's my job. Yeah, he says he finds layout quite relaxing when he has a chance to do it. This is Benjamin. Me too, which is kind of one of the biggest reasons why I have done everything in my power to make electronics stay a hobby and not a job. Okay, so actually, you know what I do want to do is I want to lay out some board edges. Just so I have some things to work with. Ah, come on. My trackball is kind of jumpy. Oh. Yeah, that's okay, fine. All right, so that is my power supply section. Let's lay out my false ground chip. And that's it right there. Okay. So knock it off. Three and 4 are the voltage divider. That's excessive. Okay. Actually, you know what? I'm going to do it differently. No, I lied. I'm going to do it exactly like that. All right, so the thought considerations I have here are that I'm thinking about rework on this board. So let me bring in the schematic and show you the schematic part that I have different size screens, so it's kind of doing weird things. So I'm looking at this. We've got 2 resistors and a voltage divider with a couple of capacitors on either side bypassing it, and then we need the center part to go to the V+ terminal. And the question is, like, if we're being completely, the reality is that this doesn't actually matter, but you generally want to make sure that your current passes across the capacitors before it goes to the load, right? So our current's going to come in from the power supply, the 3.3 volt and the ground here, and it's going to get voltage divided across these, and then we want that current to go across the capacitor pads before it goes to the pin of this. That just, it ensures like maximum filtering. So we would do this, and then move all of that closer to the chip, right? So current comes in from here, gets to voltage divided, the voltage reference is established at this point here, and then it goes into these, which get filtered across, so all the noise gets dumped out to the power lines, and then it goes into the voltage reference on the, or to the pin on the chip. The problem is that these components are kind of tall, and so if I ever need to rework this chip here, this SOIC 8, it's going to be very difficult to get the soldering iron in from the side. So you don't want to have super tall components next to the chip that you might have to rework. So like one alternative, one alternative is to move these off here, because that way I can still get into the sides of this chip. And in fact, you know what? I think I am going to do that. I'm going to do that. So it's not quite quote-unquote ideal from a from an electronic standpoint, but audiophile nerds, suck it up. Okay, we're going to do that. I think that is a good layout for this. And then the output is right here, ground A. And then that chip is completely unused, or that side of the chip. So we've got a whole nother op amp that we're not using. Okay. Now let's look at the main circuit. Bring this back up because I didn't actually put it back up. Oh, those caps go by the other one. All right, so let's look at this. We've got our 2 connectors, a cap and a resistor, and then the feedback on the main buffer. So let's set that stuff up. Again, I'm going to move this up here so I can see it, even though you can't. Sorry about that. So those are my connectors. Let's move those here-ish. Seriously? Ugh. You won't lay flush with the front of the board. Okay. That'll be close enough. Okie dokie. So now I need C2. I'm guessing that's C2 because you keep telling me it is. And then R1 and R2. R1 and R2 are down here. R2. And then U1. Okay. So we'll do that. And then we'll figure out how to route all of that in a second. So we need ground A from up here to come down here. And then those are all, yeah, see, normally when you have 4 op amps in a single chip, it's kind of hard to route traces in and out and everything. But these are all just shorts. So this is going to be super easy because that's all traces. There are no components. Hey, look, KF7IJZ, Rubbin's tracing. Hey, how you doing, Jeremy? I'm rearranging my modular cases. Saw you were live and wanted to jump in to say hi. Well, thank you. Good to see you, Jeremy. I learned a lot from your discussions of the various considerations. Thanks for explaining your thought process. That's kind of the reason I'm doing this, right? As Jeremy knows, getting me to shut up is the hard part, as I am fond of saying. So, okay. All right, well, this will actually be pretty easy to lay out, I think. Yeah. Yeah, like this will be trivially easy. Just a matter of yeah, like that. R2 pad 2, R2 pad 2, R2 pad 2. So actually I want this one on top. Okay, there we go. That's what I wanted to see. So what I'm looking at is, so the signal comes in from the connectors here, DC blocking cap, and then this is the input resistor to the input of the op amp, and then the output of the op amp is on pin 1, and that goes through the feedback resistor into the negative input, and then the positive input is here. This is our analog ground reference, right? Yeah, so that's the only pin that needs ground A. Okay, we can do this. So I may cheat and use a 4-layer board on this. I tend to do that a lot because, well, 4-layer boards aren't that expensive when you buy them from JLC PCB, and they can make routing power a whole hell of a lot easier. Oh, great gravy, so easy. Okay, give myself some space between those. And then transformers. We're just going to have a bunch of audio transformers in a row. And then we need some DC blocking caps. 9, 10, and 11. Well, there's 10. Wait, hey, knock it off. 10 goes here. 11 goes here. 9 goes here. All right. This is a purely meaningless. Hold on. Turning off notifications on my watch. This is a purely meaningless order, but the order of these here is not the same as it is on the schematic, and that is exactly the kind of thing that drives me up the wall. Oops, I should have done that differently. There we go. Middle. So now they order the same. 9, 10, and 11. Okay. Yeah. And then is that center lined? That is not center lined. Oh, okay. Oh, I like that. So this trace has to go there, this one has to go there, so I think cutting through there might be a little tight, but we can probably make it work. All right, these go on top of, on either side of that op amp. Okay. Is that everything? That is everything. Okay, so we've got a rough layout of the board here. And again, I'm just trying to like follow the flow of signals. Yeah, and we could even compact this some more if we wanted to. Like, I think I can bring this section down and maybe rotate it. I don't know. Or we don't worry about it. Boards are not that expensive, and this is way smaller than the minimum size board, so I don't think that's going to pay any less for making this smaller. With JLC PCB, I think if it's anything smaller than 10 centimeters by 10 centimeters, it's the same price. So the only reason I would want to make it smaller is to make it fit into a case, which actually is a legitimate consideration. I do have some cases outlined. Not that one. That one. Yeah. So this is the, beautiful. Okay, so this is the outline of, I've got to have one around here somewhere. I guess I just used it. Of this little cheap, crappy plastic project case from eBay. What am I doing? Going here, and I'm doing this. So it's just a little tiny cheap plastic case. Right now I've got a bandpass filter in here, a 2-meter bandpass filter that I'm using for some SDR stuff that I'm doing. But basically it's just a little cheap plastic case, right? It's got some holes on the bottom for mounting a board to. I cut these little holes for cable in and outs, but you know, the lid of the case doesn't attach other than like through friction, right? You know, it's just a little clip in place. These are like $1 a piece on eBay, and so they're super cheap. And I went through the trouble of measuring them and laying out a outline on a silk screen as a component so that I know what the shape of the board has to be to fit in one of those cases. So I'm going to use that as my board. Yeah, that's what I'm going to do. Oh, nope, just kidding. Damn it. There we go. All right, so I'm going to draw board edge. You know what? Hold on. I am not on. There we go. Mounting holes. I think I want an M3 because those are all the screws that I have. All right. Okay. Excuse me. So let's put these up against the edge of the board. Those are evenly spaced. Okay, cool. Now we can space these out a bit. I lied. I'm totally going to make these consistent because that's the kind of aesthetics thing that drives me up the wall. Oh, I may not be able to. Let's see here, can I? Yeah, I think I can. Okay. Let me... This is so meaningless, and yet it's the exact kind of thing that drives me up the wall if I don't do it. Center line. Center line. Center line. Okay. Yep. And that's too wide. That is not going to work. Okay, so I will have to space out those transformers. That's fine. Oh, that one wasn't quite lined up. That's okay. All right, you know what? Then I'm going to space these relative to the transformer. Okay. Okay. I think that'll work out all right. All right, let me do this side. Yep. So there's one dot between the edge of the circle and the case, and 3 dots between each of those. I got 1 dot there, and 3 dots there. Okay. This is going to have to be redone. This is why I don't lay down traces early in the process, because more often than not, you end up having to move things. So... Okay. I think that's good. All right. And we'll just do that. But again, I don't want to block off those connectors in case I need to rework those. So I will do that off to the side. Why are those not polarized? Huh. Those capacitors should be polarized. They are not. Why not? I bet I chose the wrong component. 10 and 10 radial capacitor through hole. Because these are all C, Oh, there is no... Why is that not... None of these are showing polarization. Rect. CP, there we are. That's what I'm looking for. Radial. That's what I wanted. Okay. I was in the wrong section. These are... What is it currently configured as? Come on. 6.3 millimeter and 2.5. Okay, so 6. So that's what we have currently. Yeah, that's good. That'll do, lad. That'll do. Okay. Save net. Generate net list. Save. Okay. Go away. Now, remember what I said earlier about exchange footprint change. I want it to change these footprints. So now we've got new footprints in there. And they are polarized. And those are the pluses down there. Perfect. Okay. Okay. Where's my schematic? Bring that back up here. All right. So I do have that C4 0.1 microfarad on the output of that. So let's make sure that's nearby. Hey, look, C4. Okay. So, okay, there's part of me that just wants to optimize the hell out of this, and then the other part of me that realizes I have so much board space I don't need to optimize. Okay. Yeah, stop optimizing, Smitty. Just do it. Okay, this is good. And that still gives me plenty of space to get in on those. Okay, first off, let's lay down a copper pour. On the bottom, make it a ground. Okay. Wait. No, I don't want the ground all the way over there. I think I only want ground here. And here I'm not even sure. Okay, I gotta think about this because I think I want my ground A to be my ground at some point. Because I don't think we have any ground over here. These are all, let me bring in my schematic and make sure. Like we have grounds on the power supply, the power connectors, we have grounds on these, but as soon as it goes through this capacitor, we are no longer using this ground, right? And we've got that ground on these here, but as soon as it bridges that capacitor, we are now on a ground A system. And then as soon as it bridges this transformer, we're on the local grounds. I do need power fed to the cap, or to the op amps. I need that ground, but my local reference is ground A. Okay, I think I want to lay out that plane differently. Okay. Generally, it's a good idea. It's a good thing that it won't let you select the ground plane just by clicking in the middle of it, because then that makes it hard to do things like this if there's a ground plane underneath you. But it does make it a raging pain in the butt to actually grab the ground plane when you want to. It's kind of insane. Okay, so I'm actually going to move this stuff closer this way, because I want that capacitor to be the bridge between ground and ground A. And I want these to be in the ground side. Okay. Okay. Hate that. You know what? I'm done with you. I don't need you. You were just there as a reference. Okay. Ground A is at the top of that chip, but I need it to be at the bottom, so I'm actually going to turn that upside down, which has some advantages as well. Okay, so that's a real ground. Actually, let me give me a little bit more here. So, do I want the ground A to be on the top or the bottom? Because with this chip, there's a bunch... No, there isn't. There's only the one. I lied. Bottom it is. So I was debating whether I wanted the ground A to be on the top layer or the bottom layer on this, and I was thinking that because there were a bunch of pads that I thought were tied to ground A, and rather than via them all through, just put the plane on the top. But no, that's not what we want. Okay. So I got my cap bridging my two different ground systems. Ground A from there will come out and tie into that one. And then all I need to do is I need to get VCC and real ground out to this. Which I think I know how to do pretty easily. Okay. And then over here, we're just going to use traces. I'm not going to bother with pores. Although I probably should. Yeah, anyway. All right. So let's dive in and do some routing. So ground, you're going to go... Nope, just kidding. Ground, you're going to go out to via and VCC, or yeah, power input. I may do a 3.3 pour. Or I may not. Because I want all my 3.3 to come from this pad right here. Okay. You know what? I am going to do a 3.3 pour on the top layer. But I want it all to come from here. Top 3.3. Because I don't want any of the current to miss the bypass cap. So I'm going to avoid that. Oh shoot. Okay. Okay. Yeah, close enough. Okay, so this is my voltage reference, and I'm going to do that. Actually, you know what? If I'm going to do it that way, I'm going to do it like this. And I'll just do it on the outsides. Yeah, that's good enough. So that ground will only get its audio, the signal from those pads. Yeah. Perfect. Okay. That's good. That's good. I like that. And then I got my two ground A's right there. So that ground A goes there. You know what? I want to add ground A to my pad, or to my power. Power. Ground A, you go over there. Perfect. Okay. Now, when I lay down a trace, it should be bigger. Yay, it is. Now, I should be able to just go like that and lay down a via. And that will tie that in. Okay. Okay. And then that goes over there. That's ugly. So this is something I'm not super keen about. Oh, shoot. Ah! Okay. Damn it. There we go. That's more centered. Got to do all that again. Wait a minute. That's what I was trying to do. Curses. Okay. Well, that's fine. That's what I wanted. Because that's the op amp that's actually doing the buffering. Okay. So grande, grande, grande. And then I want to pull ground from up there, but power ground. Okay. But I also need to pull VCC 3.3 volts from that, which is going to be a pain. I'm going to reorder these op amps to make this easier. Oh gosh, yes. Okay, so all these op amps, okay, look at these cross paths. Like this one, I have to move it up to go to the top one, but I could use the bottom one much easier. And if I swapped this one up to here, then it wouldn't have to cross as many paths to get its output up to its output transformer. These two are crossing, so I could swap these two and they would go to their respective transformers. Okay, so that's easy. Let's do that. So I wanted to swap A and B, and then C and D as well. Okay, so that's just swapping those, generate a net. And then this is not actually changing any footprints, this is just going to change the rat's nest. So you go away, you go away, you go away, you move back down there. Oh, Are those really ordered the opposite? They kind of are. Huh. Okay. Now can I move the whole thing so that that's straight line? I am kind of a... It's kind of insane how much I like straight lines. Optimized. Why are you off to the side? Because you got a trace there. Okay. I like organization in my layouts. I like clean lines. Okay. Okay, that's better. So that's moved to a different pin. Okay. So I think we want to do that. Okay. Now, that's not a good way of doing that. That's a less ugly way of doing that. Okay. So that's my mic signal. And then the only thing I have left are these outputs. Okay. That's not so bad. Yep, don't. You can make me route this by hand, aren't you? Okay, now all I need is power. Okay. Actually, yeah, I do want to do it that way on that one. So, you know, this is the easy part, but this is easy because I spent so much time figuring out how to lay out all the components so that this would be easy. Right? You know, I spent a fair bit of time figuring out where to put the components to minimize trace length and that sort of thing. I'm a little uncomfortable by that, but I don't know what else to do. I mean, we're going to have that distance somewhere. It's either going to be on this side or on this side. Yeah. Anyone on the live stream seeing any ideas or suggestions or concerns or thoughts or anything? Any changes you would have me make? So let's go over this a little bit in some detail. Power supply section is up here, right? I have it out of the way because I can. USB connector there, and then just a standard 2-pin power in for whatever external power I wanted to put in there. 5 volts comes in, goes in through a 10 microfarad capacitor, 3.3 volt regulator into another capacitor, and then a 0.1 on the output. So these are the capacitors to keep the regulator stable and to do some filtering. Then the output of that goes to this red pour, which is the 3.3 volt pour. From there, that goes into 1/2 of an op amp that is just a VCC over 2 reference for my analog ground. And the output of that analog ground goes to this ground pour. This big ground pour here, which is our ground A signal. Speaking of signals, we come in over here on the same ground reference as the USB, assuming you plug it into the same computer. We've got the input from the laptop and the input from the mic. And they are literally just connected in parallel. They share the same ground as everything else as well. Yeah, I do need that. And they're just connected in parallel, so that allows you to plug a mic in and have it be driven directly by a computer. But we are taking a tap of that audio. This capacitor is bridging it across the 2 different ground systems. This is the ground from the computer. This is our locally generated ground, analog ground, A ground. From there, we have the input resistor into an op amp. Then the output here goes to the feedback. So that's our feedback resistor there. And then that output is used to drive these other 3 op amps that are driving, and these are just voltage followers. You can see that the inputs and outputs are connected together. And then these are used to drive our output transformers. We have power 3.3 and ground coming in from our power section up here. If I were really anal, I would have these 2 leads go all the way up to this and feed off of here instead of feeding through there. But I'm deciding to pick my battles here and not worry about that too much. Although that wouldn't be that hard to do because we could just go around. Anyway, I'm not going to worry about it. Oh yeah, and then each of the transformers, transformer coupled away from our analog ground to the local ground for this particular output. So this ground here, this shield, is the ground signal coming from whatever computer you're plugging this into. And that goes to one side of the transformer. The other side of the transformer gets DC blocked and goes to the tip of the connector there. And then you have the option of shorting the ring to the shield. Because again, I don't know for sure whether that's something that computers need us to do. And then we just have that 3 times. But I am going to clean these up a little bit because because this is exactly the kind of anal that I am. I want to get a little bit more distance from those pads. There we go. Although I guess that one's a mechanical hole, so it wouldn't. You're not risking soldering to it. But still, being on a grid makes me happy. Yeah, I'm pretty happy with that. All right, this is Stephen Benke. Oh, hey, Stephen. Ooh, the mic level seems much better this time around. Yes, thank you. I had at least one comment on my stream last time that my audio level, the mic level on this was way too low. Unfortunately, OBS, or I haven't figured out how to get OBS to allow me to monitor my own audio, monitor my microphone into my headphones. So I don't hear myself through the computer, and so I can't tell when things are not leveled correctly. And so my apologies for the last episode where my audio level was pretty rubbish. This is the most annoying part. I don't like using component references on the board. I prefer putting values on the board directly. And I haven't found a way to make KiCad do that. If anyone knows how to do that, let me know. To turn off these silkscreen references and instead put the values onto the silkscreen. Because I think I'm pretty alone in preferencing values on the board instead of references on the board. I know the advantage to putting a reference on the board instead of a value is that it allows you to change it later. But I don't know. Just the annoyance of, okay, R3, what value is R3? I have to go look it up every time you want to put a component on there. Whereas if you've got the values straight on the board, then you can just say, oh, look, that's a 10K or whatever it is. And you don't have to keep looking things up in documentation reference. It's just a preference of mine. Which means, unfortunately, that I have to move all this crap off the board. And then I have to put my own crap onto the board. Those are awfully tight. I should probably spread those out a bit. Hey, George. That was me. Thank you, Stephen, for giving me the feedback on the audio. You see a short circuit? Where? Tell me where. Oh my gosh. The design rule checks. Run the DRC. Tell me whether... Oh yeah, refill for me, please. George, you must be smarter than KiCad because KiCad doesn't see anything. I know, George. I know you were just kidding. George Zaff. I'm not going to bother butchering your last name. KJ6VU. I always want to add another letter to that. I don't know why. We got George in the house, everybody. Say hi. George from the Ham Radio Workbench podcast. If you don't listen to it, the girl from Ipanema, da, da, da. So, true story, we did a live stream with George and Jeremy, and they made the mistake of letting me control the live stream with my OBS because I had it already set up and everything, and we took a break. We were just recording an episode of Ham Radio Workbench, and we took a break, a little 5-minute potty break or whatever, and I stuck on the girl from Ipanema, and when we got back, Jeremy was freaking the F out. It's like, oh no, don't put music on the stream. We're going to get about it. And I'm like, yeah, okay, whatever, Jeremy. Sure enough, like a day later, he's like, yeah, we just got monetized. So it's like, apparently YouTube doesn't like it when you put other people's music in your videos. or they're fine with it, but then there are some ramifications to your video. As much as I would love to listen to my own music while I'm working on this, and I've done that in the past, I don't fully understand what all of the ramifications of that are. Jeremy was absolutely right, and it caused some ramification. I'm not sure entirely what it is, but he was unhappy about it. So my apologies, Jeremy, for A, dismissing you at the time, and B, doing it in the first place, doing the music in the first place. But that's something that I would like to better understand the implications of, because golly, I would love to be able to listen to music while doing all of this. All right. The board looks clean. Now I can start putting down my own markings. 10 microfarads. Put that on the front silk and make it smaller. Let's do, 05 and 075. Copyright owner gets the revenue for the video. Okay, well, I mean, I don't get any revenue from my videos, so I don't know why. Okay, well, apparently I don't care, because I don't monetize my videos at all. So I guess what that did is that ended up monetizing the video, and Jeremy didn't want that, which I can understand, but yeah. Let's see here. What is this? LM1117-3.3? I think that's what it is. Actually, let me left justify that. Okay. Bah. Okay, we'll just put the 12 there. There we go. So those are my power components. What? No. That's too big. Ah, come on. Will that fit inside? Good enough. What are the values? Where's it? There it is. So I did 10K and 1 microfarads. Oh, why am I doing 0.1s for all of this? These should all be 1s. Oops. Edit. 1 microfarad. Those are 1s, and I think pretty much everything on the board is a 1. I have them labeled here as 0.1s in the schematic, but honestly, I think 1s will work everywhere. Yep, all right. I'm putting 1s in all the places. I've got 1s in all the places. Good enough. Okay, so let's put some 10s and 10s. Okay, so these are 10s, and I think I have 10s up there as well. Yep, all right. Edit 10K. Okay. TLO72, which of course I'm not actually going to be using a TLO72, but that's just dual op amp of your choice. And edit. Whoop, hey. Not a capital 4. TLO74. Okay. Quad op amp. Greg Smith. Hello, Greg. Thank you for joining me today. Well done. What's well done? My board? So in case some of you weren't here, this board is awfully large and spaced out. It honestly gives me a real hard time having so much dead space on the board. I have a natural inclination to want to shrink it, but I have these little black plastic project boxes that I picked up from eBay for like $1 a piece. So they're super cheap and you know, really convenient for little tiny projects like this. And this board size is exactly measured to fit into this little project box. So I've got the space, and it's kind of a question of, well, how much do I bother trying to optimize when I have this extra space? So that's the reason it's laid out the way it is. Okay, we're gonna do something here. Short ring. How small can I make that? Okay. Left, and then to computer mic in. What? The hell happened there? Microphone. Now, which of these ports gets used for which doesn't actually matter because they're just connected in parallel. Yeah, I'm pretty happy with this. Edit. Left. Mic splitter. There we go. These are the important parts. CC. Attribution, non-commercial, share alike, 2020. There we go. Oh, you know what? I want to include a link to the YouTube series. How self-referential can we get? So pardon me for a second while I do something on my other screen. Home, trending subscriptions. God, I can never find my way around the damn YouTube web UI. Your channel. That's what I want. Playlists. Audio building blocks explained. I think I want the... Yeah. How do I get a short link to the playlist? Share, embed, Twitter. No, that's not a short list. Short link. All right. That's unpleasant. Okay. So we're going to put that on the bottom silk. We are going to make it mirrored. We're going to want to make that 4.04.075. We'll just put that down there. Actually, I could probably put it on the top layer. Yeah, I'm going to do that. So we'll put it on the front silk and we will unmirror it. There we go. Because anybody is ever going to go bother to type that in. Jesus. Okay. I wish there were better ways of doing short links to playlists. Okay, and the single most important part of the entire board, back mask, and mirror that. Seriously? Fine. So, why do I put this on my board? You'll notice that there are little fishies with bubbles coming up. This is not a Christian thing. That's not my particular jam. This is a throwback to my BBS days. So when I was a wee lad, I was running a BBS in my bedroom, like junior high and high school, and it was called the Halibut BBS. So backstory on where I got my name. It was called the Halibut BBS, and it was actually started out as Just for the Hell of It BBS, and I was 12 years old, and my mom kind of looked at me and like, maybe not so much with the Just for the Hell of It. How about you go with Just for the Halibut BBS? And so I'm like, okay, fine. So I changed the name of the BBS, and it opened up all kinds of opportunities for ANSI art as well. I was very much a ANSI artist using the draw. Not so much on the blocks as the lines. I did a lot of ANSI art with lines and characters and whatnot. You lost my audio. Is it back? Check one. Yes. Thank you, George. I'm glad I was watching you. I don't know how much you guys heard, but okay, I'll start at the beginning. So why do I draw fish on my board? Because back in the when I was a wee lad running a BBS at the age of 12, starting to come up with a name for the BBS, and like, well, why am I running a BBS? Just for the hell of it. So I made it Just for the Halibut BBS. My mom is like, how about you go with Just for the Halibut BBS instead? I'm like, okay, fine. And that opened up all kinds of possibilities for ANSI art. I did a lot of ANSI art when I was a kid using the draw and stuff like that. So good fun stuff. And then eventually the BBS, this was late 80s, early 90s, and it ran on floppy disks, not a hard drive, and floppies die after a lot of activity, and my BBS got a fair bit of activity, and so it would just die every once in a while and need to be reinstalled from scratch, and eventually it just got shortened to the Halibut BBS instead of Just for the Halibut BBS. And so Halibut has been my brand since 87 when I started the BBS, 1987. And that's why I have halibut.com. That's why I am Smitty Halibut, all that fun stuff. And it's not because of the fish. I actually don't eat fish. I'm not a fan of eating fish. It is because Just for the Hell of It became Just for the Halibut. So I always throw these little fish on things. In all of my circuit boards, I will lay out just a little bit of ANSI art, or ASCII art in this case. And these little fish were part of the artwork that I would do. When I made like the home screen on my BBS, I would, do all the fancy colors and everything else, and I would hide these little, fish in the artwork. So I do that now. That's why I put the little halibuts on my board. And so these are on the bottom. Let's take a look at this. This is on the bottom mask layer. So what that's going to do is that's going to be a spot where solder mask does not go. And so it's going to expose whatever is underneath it. This one happens to be in the middle of a copper pore on the bottom layer. This big green kind of shape here is a pore of copper. And so it's a giant plane of copper, and so it's going to shine through the copper. The copper will shine through instead of being covered by solder mask. It's kind of one of my favorite ways of putting art on my boards. It's really nothing more exciting than that. This is, as far as I can tell, ready to order. So I'm probably going to wrap the stream here. I don't like actually ordering while I'm streaming because credit card numbers and things like that. And I've also got a couple of other boards, or at least one other board that I'm going to be ordering as well. So I'm going to go ahead and wrap the stream here. Thank you for, actually, let me save that before I do anything, and then I'll come here. Thank you very much for joining me. This is really fun. I am cleaning off the bench to do some YouTube videos someday, and it's great to listen to you design. Thank you, George. Yeah, I mean, this is my accidental YouTube channel, right? You know, I don't do produced videos. I don't do scripted videos. This is my gig. This is what I do. So I'm glad you enjoyed. I'm glad you guys are here. Thank you very much. This is going to wrap up this particular stream on this mic splitter. I will probably start doing audio building blocks explained in some more detail. I've gotten a lot of requests for both this is the satellite audio mixer thing that I actually described in the QSO Today podcast. I did this one a couple of years ago, and it's got some issues, and I want to redesign it and start over from scratch. And this one's pretty well self-contained. It's about as complex as this system, maybe about twice as complex as this system, but I can do this one pretty quickly and easily. The other board I was thinking of doing is the studio console, or the station console. This is not quite the same station console as what George is talking about on the Ham Radio Workbench podcast. This is more for contesting. I've talked about this several times on my stream here, but basically it's got two ports for headsets, like PC gaming headsets on the bottom, and then a couple of ports that go up to a radio, so like a speaker out, or speaker input from the radio and a microphone out to the radio, then of course power, and then it's got little mixers, right? So you can, each of the two different headsets here, you can mix how much of your own audio, how much of the other person's audio, and how much of the radio audio you get into your headphones. And then up here is a 2-channel mixer for each of the different microphones going into the radio itself. So it's very useful for things like field day. You know, you've got an operator and a logger sitting on an HF radio, and they want to be able to talk to each other without having to, what was that? You know, without having to do that kind of crap. So you got the microphone intercom between the two, and also the radio coming in, but only one of the microphones goes to the radio. And then there's the other knob, the last knob up here, the one sitting off to its side, is a volume for an external speaker. So the audio coming from the radio gets reamplified and sent out to a speaker. So people walking by, if you want them, or if they want to be able to listen to you, they can turn the volume up on that speaker and listen to the radio as well as you talking. So I designed that 6 years ago for field day. Wasn't able to use it that year because I'm stupid and I hooked up the power connector wrong. But for winter field day this year, in 2020 earlier, I figured out what I did wrong, and we ended up using the board, and it works great. So that's another project that I might want to kind of clean up and fix up a little bit, but that's a heck of a lot more complex. So I suspect for the audio building blocks series, I'll go back to this one, especially since this is what I describe as an example project. So I'll probably go back to this. Anyway, thank you very much all for listening. I appreciate it. I'm Smitty Halibut. You can find me on Twitter, SmittyHalibut. I'm also here on YouTube. If you want to ask me any questions or tell me about what kinds of projects you guys are doing, feel free to post in the comments below or find me on Twitter. I check Twitter a lot more than I check YouTube comments, but I do check both. yeah, tell me what you guys are working on. I love hearing about it. And yeah, until next time, I'm Smitty Halibut. Be good humans, and take care. Bye, y'all. And then now I do that awkward thing where I wait to see myself put the hand up, and then I click stop stream, because if I stop the stream too early, then it cuts off my audio. There it goes.